Let's take up phosphorus halides. Phosphorus forms two types of halides. One is trihalides, another is pentahalides. In trihalides, we have fluorine, chlorine, bromine, and iodine, although Pi3 is unstable. And in pentahalides, we have fluorine, bromine, and iodine. Pi5 cannot be formed. And even Br3 is also unstable. First, we are taking phosphorus trichloride. Its preparation, it is obtained by passing dry chlorine over heated white phosphorus. And here we have to use limited quantity of chlorine so that we get PCl3 and not PCl5. It is also obtained by action of thionyl chloride on phosphorus. P4 reacts with 8 moles of thionyl chloride, results in the formation of PCl3 plus SO2 is formed plus sulfur monochloride is formed. Actually, this is dimer of sulfur monochloride, S2Cl2. Let's take up its properties. It is colorless, oily liquid and hydrolyzes in the presence of moisture. PCl3 on hydrolysis will give phosphorus acid plus 3HCl. The way of remembering is the oxidation state of phosphorus is plus 3 and here also it is plus 3. So the halides get oxidized, get hydrolyzed to the acid having same oxidation state. It reacts with organic compounds containing OH group like acetic acid, ethyl alcohol to form corresponding halides. Phosphorus acid is formed. 3 moles of acetic acid reacts with PCl5 to give 3 moles of acetyl chloride or ethanoyl chloride plus phosphorus acid is formed. And 3 moles of ethyl alcohol reacts with PCl3 to form 3 moles of ethyl chloride plus H3PO3, that is phosphorus acid is formed. This is the structure of PCl3. It has pyramidal shape, sp3 hybridization, bond angle is around 100. H2SO4 reacts with PCl3 to form chlorosulfonic acid plus P2O5 is formed plus 2SO2 plus HCl plus water. Here we have used 2 moles of PCl3. If we use 1 moles of PCl3, then we get chlorosulfonic acid plus metaphosphoric acid plus SO2 plus 2 HCl. P2O5 gets dissolved in water forming metaphosphoric acid in the first stage. If we add further water, we'll get phosphoric acid, that is H3PO4. It directly combines with chlorine, oxygen and sulfur. This indicates that it is unsaturated compound. Unsaturated here means that its valency is not highest. That is, it can expand its valency to plus 5. So PCl3 plus chlorine react to form PCl5, which is more stable than PCl3. PCl3 gets oxidized with oxygen to form phosphorus oxychloride. And if PCl3 reacts with sulfur, we get PaCl3. It is similar to PoCl3, where oxygen is replaced by sulfur. It acts as reducing agent. PCl3 plus SO2Cl2, that is sulfuryl chloride, will change to PCl5 plus SO2. The SO2Cl2 is a chlorinating agent. So it will give Cl2 to PCl3 to get PCl5 itself will get reduced to SO2. PCl3 is getting reduced by sulfur trioxide, which is a strong oxidizing agent. It will oxidize PCl3 to PoCl3. SO3 gets reduced to SO2. PCl3 reacts with thionyl chloride and it results in the formation of phosphorus oxychloride plus phosphorus sulfur trichloride or phosphorus thiotrichloride plus PCl5 is formed. PCl3 reacts with sulfur monochloride, dimer of sulfur monochloride to form PCl5 plus 2 moles of PsCl3, that is phosphorus thiochloride is formed. It reacts with finely divided metals when hot. Silver reacts with PCl3 to form silver chloride plus phosphorus is formed. Sodium reacts with PCl3 to form sodium chloride plus sodium phosphide is formed. It is used in manufacture of phosphorus oxychloride and in the preparation of organic compounds. Let's take up phosphorus pentachloride. Preparation. Phosphorus pentachloride is prepared by reaction of phosphorus with excess of dry chlorine and we get 4 moles of PCl5. It can also be prepared by action of sulfuryl chloride on phosphorus. P4 reacts with 10 moles of SO2Cl2 and we get 4 PCl5 plus 10 SO2 is formed. Here sulfuryl chloride is acting as chlorinating agent. PCl3 will react with SO2Cl2, we will get PCl5 plus SO2 and PCl3 also reacts with Cl2 to give PCl5. Properties. PCl5 is yellowish white powder, and in moist air it gets hydrolyzed first to POCl3 and finally gets converted to phosphoric acid. PCl5 plus water gives phosphorus oxychloride plus 2HCl, and phosphorus oxychloride further get hydrolyzed to form H3PO4 plus 3HCl. These reactions also show that PCl5 has two types of bond. Axial bonds are longer and weaker than equatorial bonds. So first these axial bonds get hydrolyzed to HCl and we get POCl3, and then all the three equatorial bonds hydrolyzed to H3PO4. So these reactions also show that there are two types of bonds in PCl5. When heated, it sublimes but decomposes on stronger heating to PCl3 plus Cl2. Phosphorus pentachloride reacts with organic compounds containing OH and convert them into chloro-derivative. Ethyl alcohol reacts with PCl5 to form ethyl chloride plus POCl3 plus HCl. Acetic acid reacts with PCl5 to form acetyl chloride or ethanoyl chloride plus POCl3 plus HCl. Finely divided metals on heating with PCl5 give corresponding chlorides. For example, silver reacts with PCl5 to form AgCl plus PCl3. Tin reacts with PCl5 to form SnCl4 plus 2PCl3. This is the structure of PCl5. It is sp3 dehybridization and trigonal bipyramidal shape. These three bonds have got bond length 202 picometer and they are equatorial bonds, and these are axial bonds which are longer, having bond length 240 picometer, and they are easily broken. So first these two bonds break and then remaining three bonds break. So all the five bonds are not equivalent because they are in different planes. These three equatorial bonds are in one of the plane, horizontal plane, whereas axial bonds are in perpendicular plane. It is used in synthesis of organic compounds like C2H5Cl and CH3COCl. In gaseous and liquid phases, it has got trigonal bipyramidal structure. Sulfuric acid reacts with 2 moles of PCl5 to give sulfuryl chloride plus phosphorus oxychloride plus 2HCl. PCl5 reacts with zinc to form ZnCl2 plus PCl3. In solid state, it exists as ionic solid PCl4 positive and PCl6 negative, in which cation PCl4 positive is tetrahedral and the anion PCl6 minus is octahedral. This is the structure of solid PCl5, in which PCl4 plus is tetrahedral due to sp3 hybridization and PCl6 minus is octahedral due to sp3d2 hybridization. So this has tetrahedral structure, it has octahedral structure, this is cation and this is anion. That is why PCl5 has ionic character due to presence of these ions. It is used as chlorinating agent in organic chemistry. Oxoacids of phosphorus. First oxoacids of phosphorus acid is hypophosphorus acid, H3PO2. These days we call it phosphenic acid. Oxidation state of phosphorus is +1. It has one POH, two PH and one PO bond. Because it has one POH bond, therefore it is monobasic acid, as only one hydrogen is replaceable. It is prepared by reaction of white phosphorus with alkali. Orthophosphorus acid, it is also called phosphonic acid, H3PO3 plus 3 is the oxidation state of phosphorus. It has 2 POH, 1 PH and 1 P double bond O. Because there are 2 POH bonds, therefore it is dibasic acid. It is prepared by hydrolysis of P2O3 with water. Pyrophosphorus acid is H4P2O5. Oxidation state of phosphorus is 3. It has 2 POH, 2 PH and 2 P double bond O, which clearly shows it is dibasic acid, and it is formed by reaction of PCl3 with H3PO3. Hypophosphoric acid H4P2O6, oxidation state of phosphorus is +4, 4 POH bond, 2 P double bond O, 1 PP bond. Since there are 4 POH bonds, it is tetrabasic acid. It is formed by red phosphorus with alkali. Orthophosphoric acid, that is H3PO4. Phosphorus is in +5 oxidation state. It has 3 POH, 1 PO. It means it is tribasic acid because it has 3 replaceable hydrogen. It is easily formed by hydrolysis of P4O10 which is dimer of P2O5. Pyrophosphoric acid H4P2O7, in which oxidation state is +5, 4POH, 2P double bond O, 1 POP bond. 4POH means tetrabasic acid. It is obtained by heating phosphoric acid. Metaphosphoric acid HPO3N, that is the polymeric form, oxidation state +5, 3POH, 3P double bond O, 3POH POP bond. 3POH means tribasic acid, but it is cyclic, then only it will act as tribasic acid. Each metaphosphoric acid will be monobasic. It is obtained by phosphorus acid plus bromine on heating will give you metaphosphoric acid. These are the structure. Orthophosphoric acid or phosphoric acid, we have 3 OH group and 1 PO bond. All these 3 hydrogen are replaceable, that is why it is tribasic acid. In pyrophosphoric acid, we have got 4 OH groups, 2 PO groups and 1 POP bonds. It is also tetrabasic acid. H3PO3, we have 2 OH group, 1 PH group and 1 P double bond O group. It is orthophosphorus acid, which is dibasic acid because 2 replaceable hydrogen we have. In H3PO2, hypophosphorus acid has got only 1 OH group. It is monobasic acid. These 2 hydrogen are not replaceable. And 1 P double bond O bonds. Here we have H4P2O5, which is pyrophosphorus acid. It has got 1 POP bond and 2 POH bonds, so it is dibasic acid. These hydrogens are not replaceable. These are phosphorus oxygen double bonds. This is H4P2O6, which has got 4 POH bonds, 1 PP bonds and 2 PO bonds. So it is tetrabasic acid because it has got 4 replaceable hydrogen. Cyclotrimethaphosphoric acid, here we have got, the way of remembering is write 3 phosphorus in the center, which are linked with 3 oxygen. Each phosphorus is linked with PO bonds and each phosphorus is also linked with OH, and this is the way how structure is formed. This is cyclotrimethaphosphoric acid, H3PO3 thrice. Polymetaphosphoric acid, each phosphorus is linked with phosphorus oxygen bond, double bond and OH bond, and between every phosphorus there is oxygen atom. So that is way of remembering this structure. This is the structure of polymetaphosphoric acid. Orthophosphorus acid or phosphorus acid on heating disproportionate to give orthophosphoric acid or phosphoric acid and phosphine gas. Why it is disproportionation reaction? Because +3 oxidation state gets oxidized to +4 and -3. Hypophosphorus acid is a good reducing agent as it contains 2 pH bonds and reduces compounds like silver nitrate, and also it reduces benzene diazonium chloride to aniline. So silver nitrate plus 2 water gives you plus H3PO2 gives silver plus 4 nitric acid plus H3PO4 is formed.